So what we want to do in this lesson is that we want to, given 2 points, we want to use these 2 points and find a number of things. The first thing we want to do is to find the slope of this line. So remember that there's a formula that suggests that we can find the slope of the line by saying y2 minus y1 over x2 minus x1. Now, here it is that we have 2 points, 2 ordered pairs. What we want to do is to label them, right? Remember that the x value comes before the y value in a coordinate form. So this is x1, this is y1. If I call this x2, then this is y2. What we want to do here is to substitute these values here. So let's take a look. y2 is 5 minus y1, that's 3 over x2 is 1 minus x1, which is 2. And then from there we work it down. 5 minus 3 is 2. 1 minus 2, this is -1. So this is giving me -2. So the slope of this line segment from A to B, or a line that passes through these points, is actually -2. Now from that, we want to see if we can find the length of this line, right? How long is this line? So the length of AB, we're going to apply that Pythagorean theorem, and it says that we can find the length by using the square root of x2 minus x1 squared, all right, plus y2 minus y1 squared. So we can apply the Pythagorean theorem using the coordinates here and work that out. So let us substitute quickly. x2, so we're looking at 1 minus 2 square plus 5 minus 3 square, and we take in the square root of that, -1, be careful here, square, plus 2 square. What are we looking at? When you square -1, that's 1. When you square 2, you get 4. So the length of this line is actually the root of 5 units long, right? So basically, we're talking about 5 units. So that's the length of that line. Another thing that we can find is we can definitely try to find the equation of this line. So thirdly, we want to find the equation of this line. So let us just see what we can do. In finding the equation of the line, let us say we want to write it in the form y is equal to mx plus b, right? Where m is my slope and b is actually my y-intercept. So what I'm going to do is to remember that I have a slope here. All I want to do is to take any point, right? So I could use this point or that point, and I'm going to substitute the values for x and y along with my slope to find the y-intercept. And after that, we're just going to write the equation of that line. So let us say that, remember that my slope, which is m, was already -2. And I want to use the point A. So I'm going to take point A. If I take in point B, I'll get the same response. So I'm going to use this. Remember that this is the x value, that's the y value. So what we're going to do here is to simply substitute in y equal mx plus b. So y equal to mx plus b, y, which is 3, and this is going to equal to m, which is -2, times x, x is 2, plus b. This b here is going to be my y-intercept, right? So we have 3, which is equal to -4 plus b. In order for the b to be alone, I'll have to add 4 to both sides. So 7 is equal to b. So this is where it crosses the y-axis at 7. The coordinate would have been 0, 7. But if we're going to write the equation, right? The equation of AB is simply y is equal to m, which is -2, x plus 7. So this is the equation of that line AB. What if you want to find the midpoint of this line segment AB? There's a formula for the midpoint as well. So if we want to find the coordinate of the midpoint says x, you could say x1 plus x2 over 2, y1 plus y2 over 2. So this is the formula to find the coordinate of the midpoint. So we're still going to just use those. So x1, so that is going to be 2 plus x2, which is 1 over 2. And then my y values are 3 plus 5 over 2. This becomes 3 over 2 and 4. That's the x and that's the y. So this is the coordinate of that midpoint.